All right, so we're just going to take a break from logarithms and talk about exponential. Whoops. And so this one we have just a review of the properties of exponents. We have talked about all of these recently. Plus, we've talked about one other property that's not on here, and it's a rational exponent. So if we have something like a raised to the 1/2, not negative 1/2, sorry, the 1/2, what does that mean?
Square root.
Yes. All right, so that comes up quite a bit today. The square root exponent, which means 1/2. I think I said that wrong. The 1/2 exponent, that means square root. And then also we can have other fractional exponents like 1/3. That's going to mean the cube root. Oops. I got a little bit of a glitch in my brain today. Let's see how this goes. Okay, so keep that in mind, all those properties in mind. So just this first part is just a review of the wording that the AP pre-calculus people like to use for transformations. Luckily, this would almost 100% sure that would never be on a free response question. Transformations wouldn't. And so you aren't going to have to like memorize the wording. You just have to match the wording. Or just pick the right choice. So it's fine. I think you're going to be fine. My students last year were good. But on example 1, each one of these has some kind of horizontal transformation. So the different transformations it could be would be a translation, which is a shifting, or a dilation, which is a stretching or a compression. So what does A have? A shifting or a stretching? If we're adding, this is technically like adding on the inside. This is shifting. If you were just going to say it in normal words, you would say that this gets shifted to which direction? To the left. Unfortunately, we don't use normal words in here on this particular topic. So what you would actually need to say or match it with is that it's a horizontal translation. And then you have to describe the units for shifting left to. So how many units would that be?
2.
Close. -2. Right. And then this 3x is like multiplying on the inside, which is going to be a horizontal dilation. And for dilations, you have to tell the factor of dilation. Do you guys know what that factor of dilation would be? 1/3. Very good. All right, you guys remember a lot. All right, so go ahead and try C and D on your own. The wording is super similar to what we just wrote. All right, so on C, why is the factor 2? This is the inverse. So this would be the same as 9 raised to the 1/2 x. And so you're still doing the reciprocal of that 1/2. All right, nice job, guys. Okay, so one thing about exponential functions is that whenever there is a horizontal translation like these two, you can rewrite it to an equivalent function that has a vertical dilation, which is kind of crazy. So this is the work for it. So if we had 4 to the x plus 2, we could use the product property in reverse and change that to 4 to the x times 4 to the 2. Because I know when I'm multiplying and there's the same base, that you add the exponent. So you would add x and 2 and get this. So we do that. We did this working backwards quite a bit in calculus. So this is good practice if you guys take calculus next year. So anyway, that's the product property in reverse. And then 4 to the second is just 16, and we leave it like that. And 4 to the x stays 4 to the x. So it started off with a horizontal translation, and it ended up with a vertical dilation, which is kind of cool. All right, and so there is a shortcut if you want to use it, or we can always just go through the steps if you want to. But if you have a function, a base raised to x plus some kind of constant, you can rewrite it with a vertical dilation where you do b to that constant, that's going to be the thing in the front, and b to the x is going to be after. Okay, so let's do some of these. For example 2, each one of these has a horizontal translation, and we're going to rewrite it so there's a vertical dilation and no horizontal translation. All right, so we start off and write this as 2 to the x times 2 to the third. Because if we multiplied those together, we would add the exponents and we would get what we started with. So we're just giving an equivalent representation. All right, and then what is 2 to the third? 8. So it's just going to be 8 times 2 to the x. That's pretty much it. It's not too terrible. Now, if you wanted to do the shortcut, I don't know if it's even a shortcut. You technically are just writing 3 to this power first. So you're just kind of doing it in the opposite order, but it ends up being the exact same thing. So what is 3 to the negative 2? It's 1/9. So it is a fraction, and then what happens is that it's 3 to the positive second in the denominator, which is just 9. Okay. So on C, can I multiply 4 times 3 and make it 12? No. So someone asked me, like when they were doing their homework, if they could do that. I want you to know that rule that if you have something raised to a power, you never can multiply into it. Like it's impossible. You can separate, like with this addition, we are going to separate, but we can't distribute inside something that has a power. It won't work. So that 4 is just going to kind of hang out. All right, and then for the 3, I like doing it in reverse order. So I'm going to do 3 to the second times 3 to the x. Now, 3 to the x, it's blocked off. We can't mess with it. But 3 to the second, what is that really? 9. So we can multiply just a 9. I can multiply that by 4. And that's it. Right. What questions do you guys have? Okay, so on the next group of problems, we have a horizontal dilation, and we're going to rewrite it so we actually change the base to something else. And to do that, you use the power property in reverse. And so if I have 9 raised to the 2x, I can rewrite that as 9 squared raised to the x. Because the power property tells you if you have a power raised to a power, you just multiply those together, which is what we would get. So we're just using that one backwards. And then what is 9 squared? Yeah, so that 9 squared just becomes 81, and the whole base changes to something else. So that's going to be choice D. All right. Now these you end up having like tons and tons of options. So I think that's why Brian Passwater wanted to make these multiple choice questions, just so you wouldn't just like keep trying different things. So 4 you can write several ways, but if you look at your answer choices, how does he want you to write 4? What base? 16. So we have to figure out 16 to what power is equal to 4?
Would it be x divided by 2?
Yes. So I'm going to write that differently. I'm going to write it, I don't think that way. I just think like 1/2 x, but it's the same thing. So just make sure after you write what you think it is, just look back at the problem, make sure this is the same as that. 16 to the 1/2 is the square root of 16, and that is 4. So that is, he's right, it's 16 raised to the x over 2. Okay, so I know I've told you guys that there's 4 free response questions on the AP test. And we practiced free response 1 and 2 like crazy. We're probably going to take a little break from them. Maybe we'll practice parts of them here and there, but we're going to start focusing on free response 3 and 4. And they're both non-calculator. And so free response 4, overall, my students and overall everybody who took the AP pre-calc exam, they did the worst on. So we're going to practice more. I added these 2 examples and some problems to your homework just so we could practice questions like what you actually see on that. So I don't know if they're just harder or there's just a whole lot of places for you to make a mistake and you only get 1 point for each one of them. So anyway, I've seen some like this on either the actual test or practice test I've seen. And so we have this expression K. And we want to rewrite it so it's just 9 raised to some power, that's an expression, where the a and b are constants. And so what I would do first on one like this one is I would go back and change all of our bases to 9s. So the first one is already a 9, so that's nice. We're just going to leave it like it is. All right, and then we need to write 81 as 9 to some power. What power is it?
6.
Yes. And then what do you think you do with that 5x and that 2? You could raise it to it, or you're going to multiply by it. So either one. So if we did 9 squared to the 5x, we would just end up multiplying those. So I'm just going to go ahead and kind of do a shortcut. I think it'll be okay. What about 3? How can you write 3? 9 to what power? 1/2. Good. Because raising to the 1/2 means square root. Y'all are going to get that. Pretty soon I'm going to ask that question. Everybody's going to just yell, 1/2. All right, and then your final step is to write this just as 9 raised to a whole bunch of stuff on your exponent. So if your 9s are in the numerator, what are you going to do with the exponents? Yes. So that's going to be 2x plus, are you guys okay if I just call that 10x? I hope so. Okay. All right, and then what about if your 9 is in the denominator? what are you going to do with that exponent? Subtract it. So whenever you are dividing and they have the same base, you subtract the exponents. All right, and then your final step is just to combine your like terms. Now I'm going to write it so much like the way they wrote it. I don't know how picky they're going to be, but their exponent is in parentheses. I'm going to put my exponent in parentheses. And then they had the x term first, so I'm definitely going to write the x term first. That's it. So that is 9 to some power, some expression where a and b are constants. All right. What questions do you guys have on that? It's a lot. Like, we use every single power property or every single exponent property to do that problem. Pretty much every one of them. Okay, so let's do one more like it. I want you guys to take a second and see if you can write all of those as powers of 4. All right, so this 4, we do need an exponent because we're going to use it later. So what is the exponent for 4? Yes. So just jot that down if you didn't. It's going to help you later. All right, and then 2 is 4 to the... You're supposed to shout it out. Yeah. And then we'll multiply that by the power of 4x that's already there. And then this is going to be 2. And I multiply that by the 2x that's already there. All right, now I did not grade this question, and I honestly haven't studied the guidelines for grading that closely. So I know you have to show your work, so I don't really know what they expect there. I'll try to check it out soon. But I would take a step. I would just go ahead and write that where you're multiplying it. Okay, and then now if the 4s are in the numerator, we're going to add the powers, subtract the powers in the denominator, and then I am going to write the x term first. Like I said, not really sure if it matters, but this is only worth 1 point, so I'm going to try and do everything perfectly. Okay, what questions do you guys have? Not too bad.